Hey, Kirsten.
Hi,
How are you?
I'm good. How are you?
Good. I can't see your videos. Is your camera not working?
Yeah, my camera on my phone doesn't work.
Oh, okay. You're on your phone.
Yeah.
That's okay. Thanks for coming.
Thank you for having it.
Yeah. Did you go to the webinar on Monday?
Yeah, I went.
Good. Yeah. I'm glad we can offer these things for you guys.
Yeah.
Hey, Gloria.
Hello.
How's it going?
Good. It's getting a little cold, isn't it?
I know. Hey, Ricardo. Hey, Noah. If you can turn your cameras on, I like to see who I'm talking to, but it's totally fine if you can't. It's okay if you can't. I'm going to wait a couple more minutes. People are still coming in. All right, guys, we're going to go ahead and get started. Thanks for coming. If you just got here, and if you can turn your camera on, that would be great. I like to see who I'm talking to, but if you can't, that's totally fine. So, well, I'm Dr. Bennett, and I'm going to give you guys, this is the interest meeting for the summer research in physics for next summer. And so, you know, want to give you what information I can. If you looked at the catalog that Dr. Shoemaker has put together, it says mostly TBA for the physics program. So you won't see a whole lot of information, and that's because I don't know yet exactly the weeks. I don't know very much information, but I will share with you what I can today. So the situation is that because I'm now chair of physics, I have some summer responsibilities that I have to do that are different. Normally, my summer responsibility would be to supervise the summer research in physics, and I can still do that for part of my summer, but I can't do the whole program. So I'm looking for another instructor who will be the person to kind of take the lead, and I would be more in support for next summer. But right now I don't know who that person is, which is why I can't tell you exactly what the dates are going to be or anything like that. But I would say I'm optimistic that we will run a program. I really want to run the program. I think it's great to have this opportunity for all of you guys to do a research project during the summer. So there is, I would say, a small chance, not likely at all, but there is a small chance that it just won't happen. But I don't think so. I think we're going to be able to do it. So, but again, if you just arrived, what I'm explaining is I don't know the dates for sure yet, nor do I know the name of the instructor who kind of be running, taking the lead on the program. I would be working in kind of a support role next summer research in physics, because of the other job responsibilities that I'm going to have next summer. So what I would recommend, and I'm really happy that all of you guys are here and interested in doing a research project in physics. So I'm going to give you some suggestions. You might already know what you want to work on, and that's fine if you have an idea already. But in my experience, most students don't know what they want to do. They just know they like physics and they want to do a project. So I do have some suggestions that I'll give you for, ways to brainstorm and kind of get ideas for projects that you could do. And I would encourage all of you, if you want to do a physics project next summer, to go ahead and fill out part 1 of the application. So Dr. Shoemaker's application will come out, I believe, it's due like December 16th or 17th. Did you guys already get an email from Dr. Shoemaker explaining the different stages of the application process? Okay, double check the date, but I think it's like December 16th. You have to just fill out part 1. And all that would be your name and what programs are your top choice and your second choice and so on. You don't really have to write any essays at that point or even fill much out, except some very basic information about, you and what programs you're interested in. So go ahead and, fill that out, and let's assume that everything's going to be running and rolling. As soon as I know the dates, I will let Dr. Shoemaker know, and then you'll have that information, and you'll be able to do a part 2 of the application, which that won't be due till sometime in January. And when we get to that time, then you'll need to be able to answer some questions like, why are you interested in physics? It's helpful at that point, but in January, when you're filling out part 2, if you have just some idea of what type of physics you might want to be interested in. And I'll give you some examples. So some people really like to tinker and build stuff and make it work and kind of do benchtop experiments. So that is one type of experiment that can happen if you're a person who likes to do hands-on work. And even if we're in a pandemic, there are still hands-on experiments that you can do. So did Isha talk to you guys on Monday? Did she tell you a little bit about her project? If you went to the webinar that Dr. Shoemaker had on Monday, or if you watched the recording of that, do you guys know Isha Shakthi? So she's a senior and she's interested in biophysics. So she had a really nice experiment that she built last summer, and she did it at home because the equipment wasn't so complicated or so expensive. So we lent her some equipment from the school, and she was able to study by making different magnetic fields. And she kind of did her whole experiment inside a metal box that she built that shielded her experiment from Earth's magnetic field and other outside magnetic fields. So she could carefully control the magnetic field in her experiment. And she, because she's interested in biophysics, she had already learned how to work with planaria, which are little organisms that you could see under a microscope. So she would, and planaria regenerate, so they grow back. So she would cut them and then let them grow back in different magnetic field conditions. And she could look at them under a microscope and see how quickly they were regenerating. And she got some interesting results from that. That's just one example of sort of a hands-on benchtop experiment that is possible. And I don't know if Dr. Shoemaker explained this, but today none of us know for sure if we will be doing experiments on campus next summer. It might mean if the pandemic is bad and there's not, the safety is of course way more important than being able to come to campus, because some of these experiments could be done at home. So I don't know for sure if you're in the program, if that would be held on campus or if everybody would be at home and kind of logging in remotely like it was last summer. But either way, hands-on experiments are possible, right? Whether you're at home, there, we can let you borrow equipment. We could even buy some equipment if you needed it for your experiment. Okay, so that's one thing to think about as you're thinking about, what kind of project would I want to do, is do you like kind of benchtop experiments? And you could do biophysics. We've had students do fluid mechanics, right? We've had people build wave tanks and study, for example, generation of electricity from waves, right? So, and different buoys, if somebody made their own little generator and the waves would come and lift the buoy up and down and generate electricity, and study kind of the efficiency of that based on the shape of your buoy is another nice example. And I could go on, but basically any area of physics that's of interest to you that you can learn enough about to kind of do it yourself, build an experiment on your own, I'm game for it if you're up for it, right? So of course it has to be safe, right? So we're not going to do like high voltage things that would be unsafe to do in a lab or at home. But if we can agree to do it in a safe way, and and if it's not so expensive that we can't provide the equipment you need, we could do a benchtop experiment. The other thing to think about, and we've had some really neat projects that are code-based, or sort of writing your own code to simulate something. And that's a really important, kind of way of doing physics, right? So computers are, part of our lives nowadays, and it's part of how research gets done. So last summer, if you guys know, I'm blanking on the student's name. I can't believe I can't remember his name. But his project was, he was interested in simulating motion of rockets through the atmosphere to see. So he was trying to see if when NASA models the rockets, like when they model how a rocket travels through the atmosphere and how much fuel it's going to need to reach orbit, they kind of do that using good old Newton's laws, right? So they use classical mechanics to model that. And Newton's laws are a good model if you've studied them, but there are other models that are better, right? And so maybe you've heard of Einstein's relativistic mechanics. Well, if things travel really fast, relativity actually changes Newton's laws a little bit. And so this student was interested in, how much difference does it make, right? Can I make a better model for the motion of a rocket through the atmosphere? Would it need more fuel or less fuel, right? If I do a better model. So it is possible to do that kind of modeling. It involves stuff like, fluid drag, like the drag force. For example, if you've ever, if you're riding in a car, you put your hand out the window, you can feel the air holding back, right? The air pushes on objects that move through the air. So that can be modeled, and there's lots of neat ways to model fluid drag. So that project was entirely computational. It was done in Python. You could use MATLAB, you could use Mathematica, or various different software that you can learn to use. And there's some really cool projects that can be done that way. Orbits of satellites, right? We've had people model orbits of satellites or planets in the solar system and things of that nature, right? So there's computational and there's hands-on, and those are kind of the things that you ought to think about. As far as the area of physics, again, any area is possible as long as it's something that you need to be able to learn enough of it that you and me, or whoever your mentor or instructor would be, believe that you know what you're doing, right? So we don't want to just start trying stuff without really knowing what we're getting into. So whatever you would do, you would have to write a proposal. You would have to do a little bit of reading next spring, right? If you're accepted to this program, you would have to do some reading and work with me or the other instructor to kind of get up to speed and make sure that you have an understanding of the basics of whatever would be involved for your project. And then once you have a specific idea worked out, I want to model satellites, or I want to make a wave tank, or whatever it might be, you would have to write a short proposal and get that approved, so that you have a plan, right? How am I going to use my time once I get to the summer? How am I going to use my time to accomplish my research goal? So those are kind of those are the things I want you to start thinking about now. And again, if you weren't here at the very beginning, what we don't know today what the dates of this program are going to be. And I'm going to be providing a support role for the summer, because I have some other job responsibilities next summer, so I won't be taking the lead during the summer. But I don't know today who the instructor will be that will be taking the lead, and therefore I don't know the dates for sure. I'm pretty confident we're going to run this, so let's count on it. There is a small chance that we won't run it, all right? If for some unforeseen reason it's just impossible to find a person who can kind of take the lead, it is possible that we won't run it. And we'll know that by the time step 2 of the application comes out, which will be in January, okay? So again, step 1, which I encourage all of you to go ahead and fill out if you want to do a physics project, that you just have to put your name and, I think you have to rank your top choice programs for, are you most interested in the physics program or chemistry or biology or whatever the other options are. And that you might not even have to rank them. Did Dr. Shoemaker explain that in the webinar? What all you would have to answer on step 1? Was anybody at that webinar on Monday?
Yeah, she said you have to rank them in the application.
You do, okay.
Yeah, yes, sir, you do.
In step 1, okay. And you can rank up to your top 5. Is that what she said? Or
6? They said 6, all of them this year.
Okay.
Actually, I would double check the PowerPoint, because from my understanding, for part 1, it's only mainly for like the contact information. So you don't have to worry about the rankings for part 2 of the application, like when you're writing your essays.
Okay. So part 1, Ankita, you're saying is just your contact information?
Yes, it should be your contact information, then also the teacher recommendations.
Okay. So you have to find a teacher who, would write you a letter or a short recommendation for whichever programs you're going to apply to. That sounds right, because step 2 is where you have to write a few essays, right? About, why do you want to do this program, or, what kind of a project would you want to do? So there will be, for the physics program, assuming that it runs, you'll have to answer questions about, what type of project you'd want to do. Do you have any specific ideas? You don't have to know exactly what you want to do, right? And as I said earlier, most people don't know exactly what they want to do, but you should have some idea of what areas of physics you're interested in. And if you do have some sort of specific ideas, it's nice to let me know on the application, okay, when you get to part 2. Okay, so, all right, I have a little more information to share, but before I go on, does anybody have questions about what we've already talked about? Okay. Yeah,
Sorry, really quickly.
go ahead.
For the teacher recommendation, does it have to be like a particular kind of teacher, or would any teacher work?
So, good question. You know, so it doesn't have to be a physics teacher, for sure. I mean, it could be, but it doesn't have to be. Mainly what I would be looking for in terms of the teacher recommendation is, you know, are you a reliable person, right? I mean, are you going to be committed and actually work hard, right? Or are you somebody who's not reliable, right? Do you come on time? Do you show up, right? I mean, you know, have you demonstrated academic interest, right, in whatever course, right? So hopefully it would be, you know, since this is a physics program, hopefully your teacher would be, you know, doesn't have to be even a science or math teacher, but you know, that might help to show that you're demonstrated an interest. I mean, obviously, if you're at NCSSM, you have an interest in science and math, but you know, so mostly though, Pranette, I'm interested in things like your demonstrated reliability, motivation for academic work, right? And you know, do you show enthusiasm in your learning? Things like that, right? So we can teach you the physics, right? But you can't teach somebody to be motivated, right? Either they're motivated or they're not motivated. So I mean, I can try to help you be motivated, but that has to come from you, right? So that's kind of what I would be looking for. Does that answer your question, Pranette?
It does. Thank you so much.
Sure. Anybody else have a question about what we've talked about so far? Okay. So the other things I was going to share with you, you know, there are some really great resources online if you don't really know what you might want to do, but you know you want to do something with physics related. So I will put some things in the chat right now, and if you're interested, you could follow up on these. But I always like to suggest these because you might not know, you know, where do I go to get some ideas, right? So if you can see the chat, all right. So here's one. It is called iypt.org. All right. So if you go there, here, I'll pull it up so we can look at it briefly together. And I'll share my screen with you guys. All right, so this is the IYPT, which stands for International Young Physicists Tournament. And it is a real tournament. It is international. It's been going on for 20 years or more. And it's for high school students. And this is actually team-based. So if you wanted to participate in the tournament itself, you'd need a team. And our school did have some teams many years ago, but we haven't really been part of the tournament in many years. But the reason I'm showing you about this is they come up every year with 17 questions, 17 new questions every year, all of which are interesting, none of which you can just go look up the answer in a book, right? So if you can just look it up in a book, that's not research, right? So it has to be something where you actually have to design an experiment or do some calculations to figure out what is the answer to this. I don't know, not something you might be able to guess or look up. So, and you can look at the problems and you can look at old ones too. So let's just look at this year's. I haven't looked at them yet, so I'll be interested to see what they've got here. Okay, so number 1, design a boat that moves only due to periodic mechanical movements of its internal parts that only interacts with its environment through its stiff hull. Okay, so designing, you're going to optimize a boat to give maximum speed. Interesting. Okay. What happens when button magnets with different diameters are attached to each end of a cylindrical battery and the object starts to circle all by itself when you put it on a piece of aluminum foil? Okay, cool. Synchronized candles. Wow. Flames get synchronized. If you put two candles next to each other, they synchronize. They oscillate up and down. Okay, amazing. So, you know, stuff that's interesting to investigate that you can't just go look up stuff like this. And there's all kinds of interesting physics that you might run into when you start trying to investigate some of these. So I recommend that you look here. You can look back through the archives. They've got archives right here for the last 4 years, but if you search their website, you'll find archives for like 20 years of questions. And there's all kinds of crazy stuff that they thought of that have, you know, that are challenging. There's some of them are more challenging than others, but none of them you'd be able to like just guess the answer or go look it up. So that's a great resource I would recommend. And there's all kinds of topics in physics that you'd find there. All right, here's another one. If you look online for American Journal of Physics, you just do a Google search there. That's a journal. It's mostly written for people who teach college physics. But what you'll find, and I'll show you the website in a minute, but if you go there, you're going to find there's articles there about physics projects that were done or could be done by college physics students. And you guys are almost college physics students, and some of you have already had a first year of physics. So consider yourself college physics students, right? So if you go there and just do some keyword searches, right? So I'll go there right now and show you what it looks like. All right, so I'm going to share my screen again. All right, so for you guys, it's going to look like this. You go to American Journal of Physics. There's the homepage. You can do a search. All right, now you probably can't sign in because you don't have a subscription, but I have a subscription. So if you see something, what you can search for is the abstracts and the titles. If you see an article that you're really interested in, just email me and I'll send you the article because I can log in. But let's see what you could do. If you just do a keyword search, all right, somebody give me a physics topic. What should I search for?
Relativity.
Okay. Fine, relativity. We're going to get thousands of articles, but let's see what happens. Okay, 4,201 articles just came up in this journal. Okay. Okay. Interesting. Already you can see, I mean, even on that topic, which is a pretty abstract topic, you know, you can learn that. You can learn that at a really high level, advanced level, or you can learn it at the introductory and at undergraduate level, right? So, you know, take a look if you happen to be interested in Einstein's general relativity. Any one of these articles, if you click on it, all right, I'm going to pick this one, just a random one. And it should show me the abstract. There it is, right? So that gives me a very short description of what is this article about if I were to read it, okay? So you guys can read the abstracts yourself, search on whatever topic you want. And, you know, you won't be able to get the full article unless you have a subscription to the journal, but I can get it for you because I have a subscription, right? So that's another great one. And pretty much any topic in physics, you can find something in there, and you'll find lots of examples of projects that were done that are sort of undergraduate level stuff, which, you know, consider yourself, you know, some of them are harder than others to learn how to do, but I'll bet you could find something in there that's accessible to you. I'll give you one more, and this is another journal. This one's more for high school level. All right, it's called The Physics Teacher. And this journal is written for physics teachers like me, but a lot of the articles in there describe projects that teachers have done with high school students. So this one's really more oriented towards high school. And similar to the American Journal of Physics, you can search any topic you want in physics, and you can read the abstracts if you just go to their website. And if you see an article there that looks like, you might get a good idea for your project, if you had that article, just email me and I'll email you the article. Be happy to do that, okay? Because I have a subscription. So those two journals are really good. Again, the physics teacher is what you will find, if probably not as high level in terms of the math and physics that you'd have to know. It's a little more accessible for people who've had introductory physics, like all of you guys, I assume. If you look at the American Journal of Physics, that's going to be a bit more challenging. In some of it, will be a lot more challenging. It's really written for undergraduate level, kind of sophomores through seniors. But if you, depending on how much physics you might know, you might find something already in there that you could get into and get an idea for your project there, okay? And the IYPT is definitely for high school, right? But they're challenging. So I warn you, if you try to do some of those, they sound like, oh, this will be easy to set this up. Yeah, right. Once you get into it and try it, there's all kinds of interesting problems involved in any one of those IYPT situations, right? So you can really spend a long time figuring out what's going on with any of those. So that's my advice, right? If you're looking for project ideas, and I'm happy to talk with any of you anytime you want. If you have your own ideas, all right, could I do this, or could I do something else? Happy to brainstorm with you. And to me, the most important factor in your success, if you're going to do a physics project, is your motivation. It has to be a topic that you're really excited about, because if you find it boring, you're not going to want to do it, right? You're going to lose motivation. So I would encourage you to find something that's really interesting to you, and that motivation is what's going to carry you through to the success of your project. Because it's whatever you decide to do, I guarantee you it's not going to work the first time. I don't care what project you pick, right? That's the nature of research, guys. You try stuff and it doesn't work. And then you go back and you make it better, right? And eventually, if you work hard and you have some good mentoring and support and a little bit of luck sometimes, right? Sometimes we don't know what the best method is. So, but with persistence, all right, and motivation, you'll be successful, okay? So I want you, whatever you do, to pick something that you really like, because, you might not end up where you thought you were going to get to, but if you enjoyed it along the way, it was a success, right? You had fun and you learned a lot, and, you found something interesting. We don't always know what we're going to find when we're doing research. So it might be something completely different than what you thought you were going to be investigating by the time you get done. All right, so that's my advice. Anybody have questions about that information for your sort of project ideas or anything else you're wondering about how this program works? Okay, so let's see, is there anything else on my list? I think that's about it. So I will, I appreciate that you guys took the time to come to the interest meeting. I will, I can look at the recording, and since I know you were here, once I get more information about, the logistics and what weeks, I'll send that to you guys. Just, since you came to the meeting, I'll send that out to you guys, but it'll be on Dr. Shoemaker's website too, right? Once we know a little bit more information about how it's going to work. But feel free to get in touch with me, anytime if you have questions or through the process. So let's assume we're going to run the program. Go ahead and fill out part 1 whenever it is later this month, and that's your contact info. And there'll be some essay questions in January for part 2. And by that time, you should have all the full information about how the program's going to run. Okay. All right. I will stay on if anybody wants to stay to talk more about anything, but if not, thanks for coming, and we'll see you guys around.
Thank you.
Thanks, guys.
Thank you.
Oh, thanks, Ankita. Say hi to Sai.
Yeah. Okay, I'm gonna go, but it was a good meeting. Yeah, the recording we'll put on the website, so just send it.
Yeah, I recorded it.
Okay, cool.
I'll send it to you.
Okay, well, have a nice day.
You too.